Die Sprachübertragung beginnt jetzt. Alle Teilnehmer befinden sich im Zuhörermodus.
Welcome everybody, and thank you for joining today. If you have any questions throughout the presentation, just write a message in the chat and I'll follow up after the talk. So this talk is about using GraphQL and Lambda to build a serverless backend. My name is Søren Brammer-Schmidt and I work at the company Graphcool based in Berlin. We are basically a serverless GraphQL platform that allows you to easily create a GraphQL API and rapidly iterate. You can find me on Twitter and as well as GitHub, and you're very welcome to reach out at any point if you have questions about GraphQL. So the agenda for today: first we'll talk about why would you use GraphQL, what is the benefit, and then we'll just jump right in and start building a web shop. We'll talk about the data model we need and the 3 use cases we want to support. We want to be able to add items to a shopping basket. We want to be able to purchase the shopping basket. And finally, we want to notify our fulfillment center about a new order so they can dispatch the order and send a mail to the customer. So to talk about why GraphQL is useful, I have these 2 example APIs. It's the Star Wars API, first implemented in a RESTful manner and then in a GraphQL manner. So this is the Star Wars API. It's RESTfully laid out, so you can make requests to /people/1, for example, and you get all the information you want for Luke Skywalker. So we have done APIs like this for a long time, and it's really useful, but there are some downsides. The first obvious one is that you get a lot of information back, and maybe you don't really want all this information. But the even bigger issue is that maybe you want more information than you get back. Let's say we wanted to display the name of Luke Skywalker as well as the name of the first 3 films. Well, how do you do that? With this API, you have to first request Luke, and then afterwards you would make additional requests for the films. Like this. And again, you get way more information back than you actually want. This is especially bad on mobile applications where the round trip is significant, so you end up making maybe 5 requests instead of just 1. So how do we deal with this in traditional REST APIs? There are 2 common ways. Either we create dedicated endpoints to the screens where we just return the correct data, or we do something a little more fancy where we allow you to include query parameters in the call to embed extra information. Both of these approaches are bad because it violates the core principle of RESTful designs, and that means you lose many of the benefits. You lose the clear separation of concerns, and you lose the cacheability. We're doing this anyway because we really need to be able to quickly deliver data to mobile applications. So GraphQL is basically a standardization of these common patterns that has evolved in normal RESTful APIs. This interface is called GraphCall. It's developed by Facebook, and it's a lightweight IDE for GraphQL queries. It has built-in autocompletion, so you can do things like query all films. You can say you just want the first, and for all films you want to get back the title. Super simple. But you can then also go further and say there's a connection to a director, for example, and for the director you can query the characters, for example, and say you want, for all the characters, you want to know their names. And you get a nice list like this back. So the main benefit of GraphQL is that you are able to query just the data you need, and you get only that data back, and you can do it in a nested fashion. With this in mind, let's jump back to the slides. So what we're going to build today is a serverless web shop. The first use case in a web shop is that you need to be able to add items to a basket. So what does that mean? That's basically just a bit of data manipulation. Then you need to be able to pay for items in your basket. So that means we need to go out and talk to external services. We need to charge a credit card via Stripe. We need to reduce the stock count of the item in the web shop, and we need to mark the basket as paid. And the final use case, inform fulfillment center and notify customer when shipped. We'll use this use case to demonstrate how you can easily set up subscriptions with GraphQL that update your UI in real time. So let's talk about the data model to support this. Obviously, we need a customer. We need items, to be MacBooks, Apple Watches, whatever, and we need a basket. A customer can have a basket, and a basket can have one or many items. So let's jump into the Graphcool tool and see how we can easily set this up. So as I said, Graphcool is a hosted platform that allows you to quickly set up and iterate on APIs. The interface looks like this. It comes with two predefined types, and we can add more as we need. So let's go ahead and add an item type. What kind of fields do we need on an item? We need a name. And the name is a string. And it should probably be required. An item also has a price. And because we're going to use the Stripe API, we'll just save this as an integer. They expect it in the full sense. Again, we'll say it's a required field. We can say it has a default value of 0. Let's then add the basket type. And the basket has primary purpose to link between a customer and an item to signify what they're buying. So let's add relations. So one basket, one user. Well, a user can actually have many baskets, so let's do it like this. And a basket can have many items. And an item can, of course, be in many baskets. We also want to keep track of whether the customer has paid for this basket or not. So let's add a Boolean field. And by default, it's not paid. And we will add one last field to store if we have shipped this basket. So now we have our basket, we have our items, an item has a relation to a basket, and we have a user. And the user has one or many baskets. Let's try to explore this data model a little bit. So I showed you before the GraphQL IDE from Facebook. Let's just go ahead and play a bit with this. GraphQL has two types of queries. There are what we call queries when you want to retrieve data, and there are mutations when you want to add or update data. So let's go ahead and create a user. Again, there's auto-completion, so we can see a user needs to have an email and a name. So I'll be your first user. There you go. I have an ID. Neat. Let's also add a few items. That's a pretty expensive thing, let's call it. When you're doing a mutation in GraphQL, you always have to also query some data. If you don't care about the data, we can just query the ID field. Let's add one more item. Let's do and again, let's query all items to see what we have. We can also query all users. Alrighty, so our data model is set up. That took 4 minutes. Let's jump back to the slides. So the first functionality we want to build is add an item to a basket. So this is pure data manipulation, and we can do that with a simple GraphQL mutation. Let's have a look. I was a little bit too quick. I actually need the ID of the items to be able to add them. So let's query that. So what I'm going to do is I'll use a nested mutation. That means I'll update the user based on the ID. I will create a new basket for this user. You can do that inline like this. And is delivered is not required. You can see it doesn't have an exclamation mark, so I can leave this out. It has a default value. The same for is paid. But item IDs, this is what I care about. So I'll create a basket for myself. I will add both of our items to the list because I feel like shopping. So my user has been updated. Let's just query again to make sure it all is correct. And again, you can see we query a deeply nested structure. So there's the user. The user has a relation to a basket. The basket has a relation to items. And I care about the name and the price of items in the basket. Nice, that worked. So our first use case, adding items to a basket, was pure GraphQL. Now it becomes a little more interesting. So we want the user to be able to pay for all items in a basket. We basically want to have a checkout. So to do this, we're going to hook up our GraphQL API with Stripe using Amazon Lambda. So the first thing we need to do is go to Stripe, set up an account. If you haven't used Stripe before, it's super simple. You just sign up, you land in this beautiful interface, you go to your API setting, and it will show you two sets of keys. So there are the test keys and the live keys. The nice thing about Stripe is that you can use these two things at the same time. So you can use the live keys for real traffic, and you can still play around with the test keys to develop new features. So in our server-side code, we'll need the test secret key. Let me just go ahead and cut that. All right, so what Stripe also has is this reference page. So there are two components to Stripe. You need a front-end component that collects the information for a credit card. This information is then sent directly to Stripe, not through your servers, but directly to Stripe. Stripe will return a token, a short-lived token, that you can then send to your server to charge the card. This is nice because it means you don't have any credit card information on your server, so you don't need to go through the entire certification process. So let's extend our schema a little bit. Let's add a field to the basket called Stripe token. This is a string that is optional. So the way the user will now provide the Stripe token to the server is simply by running a GraphQL mutation that will update the basket. To get this information to a server, we'll set up a mutation callback. First, let's look at some code, and then I'll show you how to set it up in the Graphcool system. This is a short node function that basically takes in the request from the Graphcool backend and does the processing to charge the Stripe card. So on Lambda, you get in an event that contains the body. And let's quickly go ahead and deploy this to Amazon Lambda so we can set the webhook up. To handle the deployment, I use a framework called Serverless. If you are familiar with the Amazon infrastructure, you know that it can be a little cumbersome to manage. So to set up a Lambda that can respond to a webhook, you need to configure the Lambda function. You need to figure out how you actually deploy your Lambda function. The easiest way to do it is to upload a zip file, but that becomes really annoying when you have to maintain that. And then in addition to the Lambda function, you need to set up an API gateway, because the Lambda function cannot just be called directly on a REST interface. You have to call it through the API gateway. So by using this serverless framework, you can very succinctly express what you need, and then the serverless framework will manage setting up all the infrastructure for you. So in this case, we have one function, Stripe token added to basket callback. It's located in the functions folder, and the function inside the file is called handler. We also want an HTTP endpoint that is being set up at this relative URL that accepts post requests. So to deploy this to Lambda, you run serverless deploy. And what serverless does under the hood is it uses CloudFormation to set up all your infrastructure. CloudFormation is a super powerful tool from Amazon that can manage pretty much everything you can set up on Amazon through the CLI. It's really nice because you can have a declarative description of your entire infrastructure. You can check your infrastructure into Git, and you can see what has changed over time. It can be a little slow, as you can see. So now Serverless came back to me and said, here's an endpoint. This is the URL. So let's go ahead and add this as a mutation callback in the GraphCool interface. Go to mutation callbacks, we can create a new mutation callback. What we're interested in is the basket being updated. And now we can write a GraphQL query that defines what data we need in our function. Again, we have auto-completion. So I want the ID of the basket. We also want to know if it has already been paid, because then we shouldn't do anything. We need to query all the items to figure out how much we should actually charge the user. Let's take the name of the item and the price. And we need the Stripe token, of course. Let's also query the user and then name and email for good measure. So when the basket is being updated, the Graphcool API, the Graphcool platform will perform this query against the data and do a post request to this URL. So that's confirmed. Now let's have a look at the code. We're using Locker. So there are 3 main clients for GraphQL. The 2 big ones are called Relay and Apollo. Those are great when you want to do more advanced stuff, especially on the client side. What they manage really well is caching. On our server-side code, we don't really care about caching the data, so we're going to use a super simple client called Locker. Locker takes a transport that is configured with the endpoint of our API. Click on endpoint, you'll see that this is the endpoint I pasted in. So when an event comes in, we passes the body, that's our basket. Then we check if the basket is already paid, then let's do nothing because this has already been processed. If not, let's go ahead and actually use the Stripe NPM module to create a charge. We have to specify the amount we want to charge. It's easy. We just sum over all the items and their price. We're charging in euros. We need to provide a description. Again, we just have a list of the names of the items. And then we need the Stripe token. Remember, the Stripe token is a short-lived thing. It can only work one time. So we don't have to be as careful about this as we would if we were handling credit card data from the beginning. So let's go ahead and create a Stripe token and see how well all of this works. Normally, when you would create a Stripe token, you would use one of a few front-end systems Stripe has. The most convenient one is called checkout. That's the thing that generates a little pop-up. You've probably seen it before. And because I'm signed in to Stripe, here in the documentation, they have already embedded a little pay with card button that is configured with my API key. And because we're running in test mode, we can use one of the test credit cards. So this little UI widget took my credit card information, sent it to Stripe, got a one-time token back. So in your application, you would now take this one-time token and perform a GraphQL mutation. Let's go ahead and do this. We need the ID of the basket we want to update. And we need a Stripe token. Oh. I can also show you the data browser now that we added. So the data browser is just a simple spreadsheet-like view of all your data. So let's copy the ID. Let's get rid of the token, paste the ID, do the mutation. It worked. And as you can see, is paid is still false. So the mutation callback is an asynchronous process. When you're building applications at scale, it's important to always think about when do you have to tie things directly together and when can you make something asynchronous. we try to push people towards an asynchronous model as often as possible. So what should happen now is that our code is running. We create a Stripe charge. There shouldn't be an error. It should be successful. That means we would log charge when true. We would then perform a new mutation, update basket for the ID, and set is paid true. Let's go have a look in the Lambda log to make sure all of this happened. So as you can see, it was invoked correctly, and we can use CloudWatch to view the actual logs for the Lambda function. Let's limit this to the last 5 minutes. So here we logged the basket. Charge went true. That was nice. And then we went ahead and updated the basket one more time. So the second request you see here saw that it was already charged, so it just returned. So now when we query the basket, we should be able to see that it has actually been paid. That's correct. Awesome. Then we can also go to the Stripe dashboard and see if we actually earned some money today. We did. We earned a lot of money. Let's switch back to the slides. So the last feature we want to implement is inform the fulfillment center. And the reason I wanted to implement this feature is that it's a nice way to showcase GraphQL subscriptions. So Apollo has worked on GraphQL subscriptions for a year. They formally implemented build Meteor, and Meteor is of course all about live queries and event-driven architectures. So it makes sense that they have really pushed through on GraphQL subscriptions. My co-founder Johannes gave a talk yesterday at the GraphQL meetup in London about subscriptions, so you can probably find that online if you're interested. So let's go ahead and run a subscription. A subscription in GraphQL looks almost like a mutation, so you could say it's a way to subscribe to other people's mutations. We care about the basket. And as a fulfillment center, what do we need? We need to know about what is it actually we need to send out. So we need the items, probably care about the ID, maybe the name, and the price, and we care about the user. What we can also do is we can supply a filter. And Graphcool has a rich filter system built into queries as well as subscriptions. So you can say we care only about updates. Actually, we only care about updates where the field is paid was changed. So let's try to run this subscription. Then I'll go back and just for demonstration simply use the data browser. I will change this field to false, back to true. Now we should see some events popping up. Sure enough, we got the first event and we got the second event. So Now the fulfillment center is being notified about new paid baskets, so they're ready to send out their stuff. When they have sent out an item, what they would then do is go and mark it as delivered. And when this happens, we want to send an email to the customer. For emails, we'll again use an external service. There are a few to choose from. I really like Mailgun. It's super simple to set up. Again, you simply go to Mailgun, you sign up, and they, right out of the gate, send you to this page that shows you how to send a mail using curl. It's really developer friendly. So let's switch back to the code. We have another function. It imports the Mailgun node module, is configured with our API key and a sandbox domain they set up for me. So what do we want to do? We want again to be notified when the basket changes. We pass the basket. We then check, has it not been delivered? There's nothing for us to do. If that's not the case, then it has been delivered and we want to send a mail to our customer. So we set up Mailgun like this. It's a mail from the serverless web shop. We are sending it to the user who owns the basket and the user's email. And again, we just combine the names of all the items and say, you purchased these items. Let's go ahead and deploy this using serverless. So we have one more function. Let's just copy paste this. I think I got that right. So again, the serverless framework is going ahead and using CloudFormation to make sure all our infrastructure is now in the correct state. What you can do if you don't want to wait this long is you can say serverless deploy function, and that will just package the zip file and upload it to Lambda, so you don't have to do this slow process of basically diffing your entire infrastructure and figuring out all the changes. So in a few minutes, I'm done with the presentation. We will have roughly 5 minutes left for questions. So now is the time to start writing some questions, and then I'll follow up in a few minutes. Cool. Our function is ready. This is the new one. Again, we have a nice endpoint. We can go to Graphcool, set up a new mutation callback. Care about the basket being updated. This is the URL. And what do we actually need? Again, we need let's take the ID, we need the user, we need the email name, we need the items in the basket, we need the name. I think that's actually it. Let's just check the code. Oh, and we need the is delivered field on the basket, of course. So let's get that. Our mutation callback is set up. Our Lambda function is deployed. So now, when I update the basket and set the is delivered to true, I should be receiving an email. Let's see if this works. So again, I'll just use a data browser. It's nice and easy. Is delivered. Let's change this to true. And then the big moment, will we get an email? We did. Amazing. Back to the slides. If you're interested in GraphQL and how GraphQL and Serverless works together, there are a bunch of resources available. So the Slack community at slack.graph.cool is turning into kind of an industry go-to place to just talk about GraphQL in general. There's a bunch of cool people hanging out there, so I would encourage you to join. There's a GraphQL weekly newsletter. You can just Google for that. Then there's this awesome GraphQL repository on GitHub that is just a really nice list that is being kept up to date with all the cool stuff going on in GraphQL. And if you're more of a Magic Quadrant report kind of guy, you can look at this industry report that came out last month. There are some great tutorials. Learn GraphQL, learn Apollo, learn Relay. They are all interactive tutorials you go through while you learn these tools. They're really nice. There are meetups in Berlin, London, Paris. Those are the biggest ones. There are also a bunch of other meetups. It's always great fun. And then coming up in May, there's a GraphQL conference in Europe. So if you are considering using GraphQL in your company or just want to get some more insight, I can really recommend this. The keynote will be by Lee Byron, who is the inventor of GraphQL and is now the maintainer of the spec at Facebook. And there's going to be a lot of great people there. The early bird tickets sold out pretty quick, so I would recommend you to act quickly if you want to be part of this. Yeah, there's a talk about GraphQL and Lambda. Feel free to reach out to me on Twitter or in Slack if you want to talk not just about Graphcool, but GraphQL in general and how that might fit into your company and what you're building. And now let's see if there are any questions. So there doesn't seem to be any questions so far. I'll be hanging out here for, oh, there's something. There are questions. I think I probably need help to figure this out. Thank you.
Okay, hi everybody. Hi Søren.
Hi.
So unfortunately I can only see the question. So Søren, there's one question. Vladimir, he asked, what about security? How can you secure this whole queries?
This is a great question. So when you are working with traditional RESTful APIs, you think about security in terms of endpoints. So you create one endpoint and then you think about what kind of security checks do you need to implement for this specific endpoint. You can also do this for GraphQL, but it's much more natural to think about permissions in terms of your data model. So what kind of users would have access to what kind of data? So for example, you would say a basket. Who should be able to view a basket? Well, it will make sense that only the user who owns the basket should be able to view it, and the staff in the fulfillment center. So the way we express this in the Graphcool platform, I know this is specific to platforms like Graphcool because we can do a lot of work to make it really easy to set up these permission rules. But the way we do this, I'll just show you quickly. Let's say view data in a basket. This is a rule that applies to the whole model. And it has to be an authenticated user, but I want to be more specific than this. So what you can actually do is you can set up a query that specifies relations between the currently authenticated user and the model that you're trying to view. So in this case, I would say I would include the user ID and the node ID in the query. And I would say only if we can query the current basket, we can query the user, and the ID of the user is the currently signed in user, then allow it. So this is a very natural way to express permissions, and it works when you use a platform like Graphcool. But even when you implement your own GraphQL interface, I would still highly encourage you to think about permissions in terms of your data model and your relations instead of in terms of specific endpoints. So next question, how can I restrict GraphQL queries, example basket of different users? So it kind of ties into the same concept of using the graph and structures in the graph to restrict access. So for example, you could have different relations between a user. You could have a relation to friends, and you could have a relation to coworkers, and you could have different permission rules based on what relation other people are in. Oh, now the questions are coming, and that's great. Question number 3, is GraphQL a database itself, or how and where is the data stored? If not, what works well together? So GraphQL itself is not a database. It hardly has anything to do with graphs either. So GraphQL is I would think about GraphQL as a data query language for your front-end application. When you then talk about Graphcool, what we have done is combine this data query language with a platform that has a built-in database. So when you use Graphcool, you can think about it as an API that is automatically generated on top of a database. But many people, when they use Graphcool, they use it with an existing database or even in front of an existing REST interface. So it's really just about exposing data in a way that is easy to consume for a front-end application. Question number 4. Thanks for the talk. You mentioned GraphQL subscriptions. Is it possible to implement subscriptions in a serverless setup with Lambda without a dedicated EC2 instance? So the thing about Lambda is that they're short-lived. So you would need to have some kind of infrastructure that is not short-lived. With Graphcool, that is one solution. We are running the long-lived process for you, but there are also other ways to do that. I would imagine other providers coming up and have dedicated systems just for GraphQL subscriptions. I haven't seen that yet. And I also haven't seen any of the existing push messaging providers provide a GraphQL subscription API. So right now, the best bet is to run something yourself or use something like Graphcool. Question number 5, will there be a recorded version of this webinar? Yes, there will. It'll show up on the website. All right, I think our time is up. Thank you all for joining. And again, if you have more questions, feel free to reach out to me in Slack or on Twitter. I'm happy to talk about not just Graphcool, but GraphQL in general. Have a great day.